Welcome everybody, and as Rob said, I will be presenting a somewhat compressed version of the climate and water outlook today to accommodate the material that John's going to present, which I'm sure will be of great interest to many of you. First of all, we're going to look at the recent climate and hydrological conditions and trends, and then current forecast state of the key climate drivers, outlook for rainfall and temperature, and finish with the seasonal streamflow forecasts. So looking at recent rainfall, if we look at the period April to August, the reason we've selected that is that the Bureau officially declared the La Nina event at an end towards the end of March. So this map of rainfall deciles for Australia for the period April to August is really showing what's transpired with the demise of the La Nina. And as we can see, we've had below to very much below average rainfall over large parts of western, central and southern Australia, and above average for areas of Queensland. July has been very dry in the southwest of WA, and looking here at the more recent rainfall for August, we can see that that's quite a pronounced drying trend through the month of August, and there'll be some implications for that, and we'll be looking at what they are going through the presentation. So in terms of temperatures, maximum temperatures, we've generally had a very warm daytime temperatures across most of Australia, particularly in Western Australia there, where you can see some highest on record temps and very much above average temps in those bright orange and orange colours. We've had cool nights over northern and eastern Australia, and this has been influenced by rainfall or lack of it and ocean temperature patterns received over the last month and a half, and we are also seeing a pattern which is quite consistent with the drying trend, the lack of cloudiness, etc. So this is the reason why we've had cold overnight temperatures but very warm daytime temperatures in many areas. Just looking at the state of our water storages in terms of what we've seen in relation to rainfall and temperatures, the conditions recently. Very healthy state of storage levels across most of Australia, just below 95% in the Murray-Darling Basin, and compared to the same time last year, that's an increase of about 4.5%. Across Australia in total, getting up to just under 85% storage levels, which is up about 6% on the same time last year. And as we look at the capital cities, we can see that it's a fairly significant level of storages right across Brisbane, Sydney, Canberra and Hobart, up close to full capacity. Melbourne has improved on the same time last year, up to just under 77%. Adelaide's down on last year, 67.5%, and we have Perth still, despite a slight increase over the last month, still down at very low levels. And when we look at the outlook, I think we would recognise that we've got a fairly serious situation in terms of surface water in WA for the coming season. Over here, this graph illustrates the inflows that we've seen over the last 4 years, and as we can see, back in 2009, prior to the onset of that La Nina event that we saw, which kicked in the spring of 2010, things were looking very, very low, and then we had quite a significant increase. Throughout 2011, things have steadily increased, and we've seen a boost to storages again in the year to date. So overall, a very good situation, but not entirely the case for all parts of Australia. In terms of recent catchment rainfall and stream flows, for the catchment areas where the Bureau's stream flow forecasts are done, we've had in July reasonably average to above average rainfalls through that period across much of Eastern Australia, particularly up in Queensland. August, quite a different scenario. This pronounced drying trend is really showing through here, even in those areas up of central and northern Queensland, close to the coast, have reverted back to around average conditions. A little bit difficult to see on these two maps the detail of this, but basically these are our forecast sites, and the dark blues indicate where high flows were observed, the lighter blue indicates near medium flows, and orange indicates low flows that have been observed. So in July they were all showing high flows or near median flows. In August we started to see the effect of the drying with far fewer high flows recorded, although there were a number of them, particularly up in Queensland, near median flows in many sites, and you can see a few oranges starting to show through there, low flows. The other part of this story, of course, is the soil moisture conditions, and on this side we're looking at the month of July and the month of August for upper layer soil moisture, or the top 20 centimetres, 200 millimetres of soil depth, and we can see the drying that's occurred there in the upper layer soil moisture, quite significant drying in the month of August. The lower layer soil moisture, however, is still showing reasonably above average to well above average soil moisture for that deeper soil, 200 millimetres to 1.5 metres depth, and that is the residual effect of the two successive La Nina events that we have seen over the last 2 years at that depth, still persisting with those good soil moisture conditions. And of course we're measuring these against the 1961 to 1990 average for the months of soil moisture. So to the current and forecast state of the key climate drivers now. First of all, looking at sea surface temperatures in the central equatorial Pacific, we have temperatures above the average, 0.9 degrees Celsius, which is up from July by about 0.3 degrees for NINO 3.4 region in the central Pacific. And this is consistent with the conditions we would expect for El Nino, developing El Nino conditions, but still not profoundly warm at this time. On the right here, the Bureau's POAMA model, the Predictive Ocean Atmosphere model for Australia, this is the forecast for tropical Pacific temperatures going out well into the next year, through the spring, summer and into the autumn of next year. And what we can see is that the average of the model runs here is showing that we're going to remain near El Nino thresholds, but certainly nothing to suggest that we're going to move well into El Nino thresholds. So this is an indicator that whilst we might technically be in an El Nino, emerging El Nino situation, there is nothing in terms of the model forecast that would suggest there's going to be any significant shift into a significant event. And this is reinforced by looking at a range of global climate models, 7 models in this case that we've drawn upon, which are the consensus amongst the models is that we are at or about El Nino thresholds. Over the next 1, 3 and 5 months, none of the models, or the consensus of the models, is that that's not going to shift seriously into El Nino territory. It's going to stay around about at the threshold levels or just within the neutral range. So that's what the ocean's doing in the Pacific. So what about the atmospheric conditions? Well, firstly, over here, this is a map. I don't think we've shown this particular map previously, but this is a map of above or below average cloudiness. And this may not mean much to you. Well, that's probably because there isn't a clear picture emerging from this. The blue areas are above average cloudiness, the orange areas are below average cloudiness. And what we would expect to see in the emergence of a strong El Nino event would be from the eastern Pacific to around about the date line, this cloudiness massing around the equator. So that would be a clear El Nino signature, and that's not there at the moment. With the Southern Oscillation Index, the measure of mean sea level pressure measured between Tahiti and Darwin, the difference between the pressures at those two locations, the current value, or the most recent value, is 1.2. So it's within the neutral range. It's almost right about the middle of the neutral range. And that's an indication that whilst we have a signal from Pacific Ocean sea surface temperatures, we don't have a matching signal from the atmospheric conditions. And if we were really looking at an emerging event that was going to be significant, we'd want to see this coupling of ocean and atmospheric conditions, and that's not there at the moment. So they're not reinforcing each other. We're not seeing that strong event development that we would expect to see if we were going to be expecting a significant event. Now, the thing that has started to make a more definitive, I guess, impression recently is the Indian Ocean Dipole. And for those who aren't familiar with the Indian Ocean Dipole, we just put together a few graphics to illustrate the point. It's a measure of the difference of sea surface temperatures between the Western Indian Ocean, in this area up here off the Horn of Africa, and the East Indian Ocean here off Indonesia. And in the phases, the shifting phases of the Indian Ocean Dipole, which has, the measure is the dipole mode index, a negative dipole is where we have cool waters off the east coast of Africa. We have these warm waters around the north of Australia, making atmospheric moisture available and associated with rainfall across Australia. And historically, these events, this phase, the phase of Indian Ocean Dipole in the negative phase, is associated with increased or enhanced rainfall in southeastern Australia. So the thing to take from this is that the signature is largely in the southern part of the continent, and particularly in the southeast where it has the most profound impact. And we're looking at decile 7 to decile 8 rainfall in these negative IOD phases. The positive phase is the mirror image, the opposite, where we have the warm water off the east coast of Africa, and we have cool waters to the north of Australia and around the Indonesian archipelago and maritime continent. And conversely, these positive IOD events are associated with a deficiency of rainfall across the Australian continent, and you can see that it is a more widespread impact. So the distribution across the Australian continent is far more extensive. It does impact further into the north. But again, the main impacts tend to be focused on the southeast of Australia, and we're talking about rainfall deciles of decile 2, decile 3 associated with these events. So, if we look at the current conditions in the Indian Ocean, we have warm water off the east coast of Africa, we have a pool of cool water, but it's not that significant at the moment. They're week ending 16th of September off Indonesia, so it's not a classic signature. And the other thing to note is that we have this residual pool of warm water sitting off the West Australian coast, which is really a remnant of the La Nina's, the last La Nina event, where this warm water off Western Australia has been fairly persistent over the last several years through the two La Nina events. And the fact of its persistence is something which is not easily explained, and our climatologists are not completely sure why this is persisting so much with this dipole event having developed in the last 8 weeks. So in terms of the values, again, we currently have a positive value at the 16th of September of 0.63. It's been positive, in the positive range, above this threshold here, which is 0.4 going into this positive IOD range. Minus 0.4 indicates a negative IOD. And it's been hovering around positive for the past 8 weeks, and it's likely to remain positive throughout the remainder of the spring. And now the POEMA forecast for the Indian Ocean dipole going forward, as we saw before for the Pacific, this is for the Indian Ocean temperatures, and basically it's expected from this peak to move into neutral territory as we move through the spring. Now, with the onset of the Northern Australian monsoon, the Indian Ocean dipole would normally break down anyway. So we're expecting the full impact of the IOD to be over the next month or two, and then we should see it decline fairly significantly beyond that. So the outlook for rainfall and temperature, firstly to temperature, maximum temperatures up here. We have the percentage to which the forecasts, this is from the Bureau's statistical model, it's the one that goes out publicly on our website, and it is showing how well our statistical forecast has been consistent with what's been observed. And as you can see, there's a fairly large wide area where the consistency has been not as good as it is in other parts of Australia, and that coincides with this area here, this wide area in the forecast map. We can see that for Eastern Australia, we're looking at 80% or greater chance of above average maximum temps. Over here, we're more or less what we would talk about as around climatology. In other words, there's about an even chance that you would get above or below average in that area based on the consistency of the forecasts. And here for minimum temperatures, you can see that the shift is to the west here for the chance of above average minimum, still at above average, a chance of above average overnight temperatures is still relatively high, 65 to 75% chance of above average minimums in the east as well, but a greater certainty of that in the west. So, to the rainfall outlook, and again, you can see the percent consistency up there. It's at this time of year reasonably solid right across the country, except for a few small areas in the white and cream colours there. And the outlook is for drier than normal seasonal conditions in parts of southern Australia. The very strong signal for below normal rainfall down in South Australia, Victoria and Tasmania. We have a couple of areas where it's suggesting wetter than normal conditions in southwest Queensland and in Western Australia, and that's really associated with the warm ocean conditions off the coast of WA. So the statistical model is picking up that temperature anomaly in the ocean, and based on the historical observations is showing that there's an increased chance of rainfall in WA, and this would be a flow-through effect into southwest Queensland. This is the outlook from the Bureau's POAMA model. This is an experimental product, but the POAMA dynamical model will become the operational model for the Bureau in the not too distant future. So we have been comparing the two at the briefings just to see what the differences may be. And whilst there's a lot more red areas there, basically indicating that the chance of above normal rainfall is very low, 20, 30%, 40% in these yellow colours here. And that may look significantly different. It's not actually that different. The thing that isn't being picked up are the two areas where we expect some possibility of above average rainfall here, but over in WA it is picking it up. And talking to Andrew Watkins from the National Climate Centre about this, Andrew described it as more or less the POAMA model is not certain which of the influences is going to prevail here. These warm sea surface temperatures off Western Australia, or the Indian Ocean dipole, which is really what this signal is about. So the POAMA model is indicating a stronger, more definite signal from IOD, but at the same time we've got these two things that are both, I guess, struggling for influence. So the outlook is a result of warmer waters both in the Central to Eastern Pacific Ocean and the Indian Ocean. So it's a combined effect, but the Indian Ocean is asserting more of an influence at this stage. So, key points for climate. We've had dry conditions over the last 5 months over large parts of Australia. The tropical Pacific remains close to El Nino thresholds. We have a positive Indian Ocean dipole underway, which we expect to see decline towards the end of spring. We're expecting warmer than normal October, months of October to December over most of Australia, and drier than normal over October to December over southeastern Australia with a higher degree of certainty. And just moving on now to conclude with the streamflow forecasts. So these are the forecast areas: Victoria and southern New South Wales, where the streamflow forecast sites, the operational streamflow forecast sites for the Bureau. These pie charts show the three colours that we saw earlier for the observed streamflows. Orange being a likelihood of low flow, the light blue the likelihood of near median flow, and the dark blue the likelihood of high flows. And basically we're looking at the probability of either of those three, which divided into these terciles of low, near median and high flows, and each pie chart shows the projected probability of stream flows in each of those categories. And averaged across Victoria and New South Wales, predominantly the outlook is for near median flows. Looking further north, northern New South Wales and southern Queensland, some of the sites that have more recently come into the operational forecasts. A number of areas, again, near median to high flows. A couple of sites where these ones in grey are where the skill or missing antecedent conditions are not that good, so we don't have the confidence in the forecast that we have with the others at those particular sites. And finally, for Cape York Peninsula and northern Queensland, near median or low flows more likely for the period September to November. And just, we thought it was worth making a point about flood risk given the current conditions at this particular time of year. So again, just going back to what we looked at previously with soil moisture, we have in the lower layer we still have very wet catchments across most of Australia, the exceptions being southwest WA and western Victoria. And of course John's going to talk about bushfire risk in his presentation. So these are all factors that will contribute to the bushfire risk scenario across Australia. We've got storages at very high levels, many well over 75%, but we've got an outlook for drier conditions. So if we had these conditions and we were forecasting a La Nina event, then we might be concerned that we would see a repetition of the kind of floods that we've had in the last couple of years across various parts of eastern Australia. This is much less likely in El Nino conditions, but it is not unprecedented that we have had significant flood events during El Nino years, and one that comes to mind is 1991, 1992, the summer period, where we saw really significant impact of floods on the Sunshine Coast in an El Nino year. But we wouldn't be expecting to have significant regional scale flooding occurring as a result of the climate conditions. It will be, if there is flooding, it's going to be due to the weather systems that prevail through the wet season, and we can get flooding at certain locations anytime through the wet season if we've got the right weather conditions. So the key points: near medium flows are forecast for most forecast locations through the period September to November. We've got high storage levels and high soil moisture, and floods may occur even in El Nino events. However, they are less likely and they are typically less widespread than we would otherwise expect in normal years or La Nina years. Any questions?
Thanks, Gary.